Lastly, we are going on this list, and today we will talk about Sobel operator in here, and the people who are interested in the mathematical side what this Sobel operator actually means, they can checking in here. Actually, this mathematical algorithm is invented almost 50 years ago and still is used by many people, also because it's usable and it's still good. So today I will just talk about the parameters, which parameters is taking and what does these parameters actually doing. I will talk about this. Let's directly going on the code side. Actually, before starting, I wanna show something I will use in this video. Before I didn't show, that's why I want to use. If people already know, they can directly skip on this part. Actually, I will use in this video this picture to show the results, to explain Sobel operator. And before starting, I wanna talk about a new function which is name window, and let's calling this input. After this taking string and a flag, which is this flag taking this kind of flags, this kind of parameters, and all of them is in different functionality. I wanna use window normal in this video. That's why I want to show this and one more thing in here. If I use like this, and now it's small and I can resize it easily in any size I wanna. I just want to do this in this video to show the results more effectively. In this point here, just the im show string and this should be same. The other thing I wanna show you, I wanna use a loop in this video to show the results because I wanna update them also always. Let's copy here, and before we talk about wait key, but not very detailedly, let's do something here like integer c is equal to wait key 1 millisecond, then delete from here, and let's do something here like if char type c is equal to c, then write to the console like pressed to c. Like this, and let's copy this and do many times. I will tell why I'm doing this, you will understand soon. Let's do this is a couple of times, 1 2 3 4 5, maybe enough. This is not actually like that, sorry, my mistake. This should be chart type and this should be chart type, and let's copy again. Okay, if press to Q, for example, make it exit, but before exit just tell press to Q, break, and let's say this one A, this one S, this one D, this one F, this one Z, this one X, this one C, and let's change these two. Okay, let's try this code. Now I will press some key from my keyboard. Let's press X, and let's press C, let's press Z, and let's press D, let's press S, and when I press Q, it's done. Yeah, I wanna show this because in here I'm actually in every loop I'm checking the keyboard which one I hit, then I'm checking them according to which one I hit. I will update some parameters in here. According to that I will change my output image. I will just show the results according to Sobel filter parameter changing. Before starting, let's make an output window also beside that, like just before window normal, and also let's define a mod for output output image. Yeah, I think that's now done. Let's continue in Sobel side now. It's taking some parameter as you see here, not see from the documentation, just calling in here cv Sobel, and it's want us from input image which is image. By the way, I'm reading the image in grayscale. Then output image is, we already defined it. Then it's want us from depth, which is the also image type. We are using 8-bit image, so it should be also 8-bit one channel. That's this is unsigned char 1. The 1 meaning is the channel number. We're using grayscale, so it's 1. We are using 8-bit, which is maximum 255, the index value of each pixel. That's why this parameter should be like this. Then other one, what is want, int dx. Let's define here dx, and this is the meaning of dx is derivative x from the equation, but I will not talk about equation. I will just tell what it's exactly mean in the experimental. Dx, let's say 1. By the way, dx and also derivative y is just taking 1 or 0. Don't put other values for these things. Dx, dy, and the Sobel kernel size, which taking 1, 3, 5, 7 or 9. Above is not good to use. So let's say Sobel kernel size, and let's give it the default value, which is 3. Then what else? Then scale factor. I will talk about all these things after I finish this initialization. Let's call it with the 0 at the beginning. Then scale, after scale delta is also, I will talk, delta value is equal to 0, let's say again. Then the value, what else? Border type not important, I also said in previous videos. Now this will give me the output image. Let's see the result before talking about parameters. Let's make this output, which I defined in here, output, the name window, and here is output image, which I wanna show. And here is the result. You see nothing because we give something 0. Let's make this for now just 1 to see. Yeah, now we are seeing something on the output. Now I will talk about parameters, but to make you explain very well, let's make something here. Now also you will understand why I did these wait key stuff in here. First of all, when I press to A, actually I wanna increase the derivative x like this, not like this, sorry, I wanna do like this, derivative x, if derivative x and derivative y, if like this, then I will make derivative x is equal to 0, else derivative x is equal to 1. In here I made like this because if derivative x is 1, which is this only take 1 or 0, like this also only taking 1 or 0, you can think this as exist or non-exist, like true or false also you can think. These are taken like this. Also they cannot both taking at the same time 0 0, so this cannot be 0 and this cannot be 0 at the same time. In this, when I pressed A from my keyboard, if dx is 1 and dy is 0, shouldn't be entered, because if entering, both will be 0, so Sobel will not work and the application will crash, will giving error. So this should be 1 to be entered here, so dx also should be 1. If entering here, dx anymore 0, else dx will be 1. So same thing let's do for the dy. Like this, then in here should be same, just I wanna change here dy and here dy, derivative y, these two like this. Let me showing you the meaning of this. This is in A, this is in A. Now I will show you what I mean. When I pressed A, as you can see, it's entered here and make the x 0, derivative x now 0. When I press again A, now it's back to normal, like this. Now dx is 0, for example. If now I'm hitting the s, which is will enter here, when I press, nothing happen. I'm pressing here, but nothing changing, because if it's not entering here, because of both shouldn't be 0. Now back to here, now I only pressing s, now s directory, derivative y is 0, derivative x is 1. To explain this before all, let's pressing A again, now derivative x 0, so you can see from the image the lateral, the horizontal lines more seeable. Now I'm pressing A again, it's back to normal. Now making derivative y 0. Now as you can see, the vertical lines is more seeable. So you understand first two parameters, derivative x and derivative y. If you make derivative x 0, it means the horizontal one more seeable, focusing on the horizontal lines. And if you're making derivative y 0, it's focusing the vertical lines in the picture. So if you make both is 0, it's making a combination and it's more giving a more good results generally. Now exit, then continue. In this part, I wanna make the increasing the Sobel kernel size, like Sobel kernel size plus minus plus equal to 2. It should be increased 2 plus 2 because it cannot be even number. If I'm pressing F, I'm expecting it to decrease again, but it shouldn't be minus at the same time. So I wanna do like if it's bigger than 1, then if like that, I wanna decrease 2. Let's try this. Now I'm increasing, decreasing, yeah, like that. Before explaining, let's do the others also. Scale factor, let's do it, scale factor increment at z, and scale factor decreasing in here also. And what else we need? Delta value also, I need one more, looks like. when I pressed V, let's make delta value plus plus. Now delta value minus minus. Now we can continue. Actually, I talked about this derivative x and derivative y parameters, what's exactly meaning. Now both is 1, as you can see here, and this is optimal way. I don't want to make a s like this. If you really want to focus on the horizontal or vertical lines, according to that you can change this in your application. Before Sobel kernel size, let's continue on scale factor. What's exactly scale factor meaning? Now I'm making before, let's do this first. Let's focusing, let's zoom. You are see the here the index values of each pixel, which I focus in here in these coordinates. And now I will press the scale factor increasing, which is Z. Now I will press Z. As you can see, the scale factor increasing, which is 1 before. When I have to decrease with X, yeah. Increase, now increase again. As you can see, scale factor increasing, and the, for example, let's focus on zeros not changing. In here, this is 37, for example. When I'm increasing, pressing Z, it's become 41. Now 45. Now 49. Now 43. According to you increasing this scale factor, also the index values increasing according to that one. In the big image, when you increasing, we can say it's making more seeable. This is also a sentence we can tell. When I press X, decrease. When I press Z, it's make bigger. This scale factor only playing with the index numbers. It's just increasing the index values. When I increase like this, it's just making the lines more seeable. When you decrease, also like this. You can find the optimal value for your images later. Scale factor like this. What about delta value? Now let's increase the delta value. In here, you should pressing C. When I press, you see the changes. What's actually happening? Now I will talk about that. Let's pressing V now. Yeah. What's actually happening? Now this white line, you see, let's focusing in here. This is 25.5. When I increase it now I'm increasing. As you can see, the already full pixels, which cannot increase anymore, staying a constant, but the neighbor pixel increasing, but the black ones not changing. So when all is becoming almost full, but the black ones at the beginning, which is the neighbors of white lines at the beginning again, then they becoming white. This delta value also like scale factor doing making the more white if you increase it. If you decrease, it's becoming more black. The most important one we didn't talk about, Sobel kernel size. Let's make this little back to normal like this. Now let's pressing the S, which not S, kernel size increasement by D, decreasement by F, D and F. This doing these two gradient which in the equation, just making this sizes bigger. Now we're using 3 by 3, and if you increase it, it's also increasing that column and row of that data. But optimal size, which is default one, also is 3. Also I advise you to always use 3. 3 is really effective. If you make it bigger, for example now is 5 or 7, 9, more noisy data. Actually little complicated I explained, but this is simply Sobel filter, not Sobel filter, but operator generally is calling like that. We use these things to finding edges. If you're playing with parameters, or if you know where to use which parameter, and you can decide your parameters in your site. We also talked about the pressing keys in this tutorial. We will use this later also. In this loop, always updating. We can use this method later. This name will also effective to use. And also other thing, for example, this is little noisy in this part, which we don't need in the actual image in here. These things you can eliminate by putting a Gaussian filter after this, or bilateral filter, or median filter, which we talked before in previous video. By putting here a Gaussian filter, you can eliminate that noise also. Yeah, simply Sobel filter is like this. It's used for finding the edges. For this video I think it's enough, and see you in the next videos.